Right, good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikhulile Ncube. This lesson is brought to you by the Gauteng Department of Education. Right, we're going to continue with our lesson, which involves some revision. Okay, we're going to do a lesson content part and also revise. Okay, since we are preparing for our examinations. Right, today we're going to focus on Euclidean geometry, and then we're going to deal with riders in Euclidean geometry. We did Euclidean geometry in the previous lesson, and then we'll do other topics under our revision program. Right, so by the end of the lesson, you should be able to solve problems and prove riders using the properties of what? Of parallel lines. Okay, properties of triangles, quadrilaterals, and then the midpoint theorem. So we're going to be using the properties of these concepts or these things like the parallel lines, triangles, quadrilaterals, and midpoint theorem to solve riders. Okay, right, refer to the CAPS document, page 10, page 14, page 25, and examination guidelines, page 7. Okay, right, what are we going to use? Like I said, properties of parallel lines cut by the transversal. Do you remember those ones? We talk about what? Corresponding angles. We're talking about alternate angles. We're talking about co-interior angles. Okay, do you remember those ones? Okay, and then we're going to talk about triangles and quadrilaterals. Triangles, remember similarity, congruency, properties of parallelograms. We're going to be using that a lot in today's lesson. Like similarity, we talked about that. Congruence, we talked about that. And then the midpoint theorem. Do you remember the midpoint theorem? Right, we're going to use it today. Right, now, the paper 2 is structured like this. You have Euclidean geometry contributing 20 marks out of 75. So it's a lot of marks. And then analytical geometry, which is coordinate geometry, 15 marks out of 75. And then trigonometry, which is 30 marks out of 75. And then statistics, 10 marks out of 75. So now we are doing Euclidean geometry. This is the last time we're doing Euclidean geometry, meaning that under revision, we're going to look at analytical geometry, trigonometry, and statistics. Okay, right, let's look at the common errors that we find when we are marking your work and misconceptions that you must take note of. Right, incomplete or incorrect reasons. Euclidean geometry, you have to have the statement and the reason. The statement and the reason must correspond. They must be correct or appropriate. Okay, naming angles incorrectly. Okay, that's a common error. And then wrong assumptions. In Euclidean geometry, don't assume. You see a line drawn like this, and then you say it's diameter. No. If you are not told that it's diameter, then don't assume that it's diameter. It's just a chord. Okay? Right, so we don't assume in Euclidean geometry. We use the information that is given. Don't do assumptions. Right, failing to indicate constructions when proving theorems. Right, there's proof of theorems. We did the proof of the midpoint theorem. We're going to revise it. Soon after this, we're going to revise that. Right, every proof is a construction. It is very, very crucial that you do your construction. If you don't do your construction, you won't get your marks. Okay, it's like the key. The construction is like the key to get your marks when you're doing what? The proof. You do your construction, then you can do what? Your proof. The first thing you do is construction. Please remember that. Even when you're going to grade 11 now, you remember that you're going to be doing more proofs. It's construction first. Right, now let's revise. Given triangle ABC, take your time reading the question. See triangle ABC. Do you see it? Do you see triangle ABC? Okay, good. And that AD is equals to DB. Do you see that? Is it indicated? Yes, it is. AD and BD there is indicated. If it is not indicated, indicate that on your diagram, on the question paper. We don't want people who are going to come out of the examination, their question paper is just, you haven't written anything, you haven't highlighted anything on what? On your paper, especially with Euclidean geometry. Don't be ashamed of using highlighters and colors on the question paper, on the diagram. Work on the diagram. Okay? And then AE is equals to EC. Is it indicated? Yes, you can see this. It is indicated there. Right. If it was not indicated, I was going to indicate that. Right. Prove that DE. Do you see line segment DE? That is DE is equal to half of BC. And then that DE is parallel to BC. We want to prove that. We did that in the previous lesson. So now I'm just going to be asking you questions. You just answer them. You don't need to write a lot of things, okay? Right, let's start. Extend DE to F such that DE is equals to what? Now, I want you to draw this triangle and then extend DE to F, and then you put your answer here on this space. I'm going to give you 1 minute to do that. Okay, just draw the triangle and then extend it to F such that DE is equals to something. Do the construction. That's the construction we have to do. 1 minute. Welcome back, grade 10s. Let's see what you managed to do. But before we move on, let me remind you about the WhatsApp line 064 748 8913. Send your questions, send your input, send your answers. We'll be very glad if we get some of your work. Please do that. Right, did you extend like this? Okay, that is EF, such that DE is equals to EF. You extend that. That's the construction you do. So DE is equals to EF. If you didn't do that, just do it so that we can move on together. Okay, just do that. So now extend DE to F so that DE is equals to EF. Okay. Right, let's move on to the next one. Right, I'll try to move slowly, but if you feel that I'm fast, please let us know. 064 748 8913. Right, now DE is equal to EF. What's the reason? Okay, say the answer. Say it. DE is equal to EF. What did we do? We constructed that. We constructed EF. So DE is equal to EF because of construction. Okay, that's the reason you put them. And then E1, angle E1 is equals to angle E what? I've given you a clue. Right. Angle E1 is equal to which angle? That angle and E1, they must be vertically opposite. So angle E1 is equal to which angle? It is equal to angle E2. Do you see that? Angle E2. E1 and E2 because they are vertically opposite. Now, okay. Now, angle side AE is equal to which side? Side AE is equal to which side? Is equal to side what? EC, because it's given. Okay, side AE, this side and this side. It's given. Okay? Which other sides are equal? DE and EF. We've done that. Oh, so now we've side and then angle and then side. Okay, DE is equal to EF, E1 is equal to E2, AE is equal to EC. Then what can we say? Side, angle, side. Look at these two triangles. These two triangles. What can we say about them? This triangle and then this triangle. Look at these two triangles. What can you say about them? DE is equal to EF, E1 is equal to E2, AE is equal to EC. What can you say? The two triangles are what? Are congruent. Okay, why are they congruent? Congruent means exactly the same. Okay, exactly the same. Okay, so that's congruency. So the triangle DAE is congruent to triangle FCE. Why? Because of side, angle, side. Now, remember congruency of side, angle, side, angle, side, and side, side, side. Now, which side is equals to 80? Before we move on, which side is equal to 80? Which side? For the other triangle, which side is equal to 80? AE is equal to EC, DE is equal to EF, and then 80 is going to be equals to FC because of what? Congruency there. Even here, when you do your eyebrows, right, you see that listen, DA, FC. Do you see that? Or AD and CF. Okay, these sides are equal. AE goes with CE. You see that? AE and CE are equal. And then DE and FE are equal. Do you see that? So now we can see that from congruency. Okay? Right, now, these are the two triangles we're talking about. And then now, what can we say? D1, let's look at the angle D1. It is equal to which angle? D1. Let me go back a bit. Right, let's look at congruency. Right, angle D is equal to angle, which angle? D is equals to F. Okay, do you see that? Angle D is equal to angle F there. Okay, so now angle D1 is equal to what? Angle F because of congruence. So these two angles are equal. Now, what type of angles are these? If you look at side AB and side FC, what type of angles are these? They are, remember, the Z, the N. Okay, they are alternate angles. They are alternate angles. So these alternate angles are equal. So what does that mean? These alternate angles are equal. D1 and angle F, they are equal. What does that mean about line AB and line FC? What does that mean? Line AB and line FC are parallel because the alternate angles are equal. Okay? When the lines are parallel, the alternate angles are equal. When the alternate angles are equal, the lines are parallel. Okay? Remember that. So now AD is parallel to FC because of alternate angles. When I'm saying AP is the same thing because AP is a straight line. Right, now, do you see that? These are parallel. Okay, so we can say that actually BD is parallel to FC. Okay, now we have two opposite sides, BD and FC. We know that they are parallel. Once we prove that they are equal, then we can conclude and say BDFC is a parallelogram. So we need to prove that FC is equals to DB now. Okay, let's see. We said AD is equal to FC. Do you remember that? Because of congruency. Do you remember that? But we're given that AD is equals to DB because we're given that. Because D is the midpoint. So now we know that. Okay. So now BD is equals to AD. It's given. BD is equals to AD. Given. And then AD is equals to FC because of congruency. Do you see that we are saying BD is equal to AD, CF is equal to 80. So BD is equal to 80. CF is equal to 80. Therefore, BD is equal to CF. Like I said in the previous lesson, X is equal to 2. Y is equal to 2. Therefore, X and Y are equal. You see that? Now, BD and CF are equal to the common thing. So, both of them are equal. So, BD is equal to CF. So, now, BD and CF, they have two things. One, they are parallel. Two, they are equal. And then when the opposite sides of a quadrilateral are opposite, what am I saying? When the opposite sides of a quadrilateral are parallel and equal, it means that quadrilateral is a parallelogram. When the opposite sides of a quadrilateral are parallel and equal, therefore that quadrilateral is a parallelogram. So it means now we can say that DBCF is a parallelogram because the one pair of opposite sides is equal and parallel. So now, meaning that if this is our parallelogram, then it means that what? DF is parallel to BC because it is a parallelogram. Opposite sides of the parallelogram are parallel. So now DF is equals to BC, and then DF is parallel to BC. So these sides are parallel and equal. So now we are saying DF is equal to BC. Okay? So DF is equal to BC, meaning that where there is DF, we can write BC. Where there is BC, we can write DF. Now, and then what's the relationship between DE and DF? DE is half of DF. So we're saying DE is equal to half of DF. And then we say that DF is equals to BC. So we can remove this DF and replace it with BC. You see that? So DE is actually half of BC. We have proved that. That's the first part of the midpoint theorem. DE is equal to half of BC. And then are they parallel? Is DE parallel to BC? Yes, because DBCF is a parallelogram. So DE is parallel to BC. So we have proved that the line segment joining the midpoints of the two sides is parallel and what? And half the size of the third side. That's midpoint theorem. That's what we did in the previous lesson. Okay? Now we need to go to our first activity. That one we're just going through the what? The proof. Now we're going to be doing question by question. Remember, you try first, then I'll explain. Right. Read the information. Okay? I'm not going to move the slide. I want you to read this information for 1 minute. Everything. Read the information. If you want to draw the triangle, do that so that you can work nicely on them. Okay? For 1 minute, let's try that. Okay? 1 minute. Right. Welcome back, greetings. In the diagram below, triangle ABC. Look at that triangle ABC is similar to triangle DEF. Do you see triangle ABC and triangle DEF? Okay. Sometimes we talked about this in the previous lesson. Sometimes it's difficult. These symbols for similarity and congruence confuses learners. We say that if you want to remember, just write the words. Similarity. Okay. There's an I here. You see that? So this is similarity. Those three I's there. And then congruency. Okay. Congruency. Right, the E there, that means congruency. Do you remember that? Okay, you can use that to remember that. I use that a lot. So now, so triangle ABC is similar to triangle DEF. Angle A is equal to angle D. Indicate that on your diagram. Is equal to X. You can see that this angle is equal to this angle. They are equal. Angle B is equal to angle E is equal to Y. This angle and this angle are equal. Both of them are equal to Y. Angle C is equal to angle F is equal to T. This angle is equal to this angle. Both of them are equal to T. It is further given that AP is equal to DE. I can indicate that AP is equal to DE. Okay, and AQ is equal to DF. AQ is equal to DF. Prove that triangle APQ is similar to triangle DEF. You see, I'm making a mistake now. Is this similar? No, it's not similar. Triangle APQ is congruent. Exactly the same. Right, triangle APQ is congruent to triangle DEF. Let's try that question. Right, 2 minutes, okay? We're answering question what? 1, 1. Prove that triangle APQ is congruent to triangle DEF. Let's try that for 2 minutes. Welcome back, greetings. Okay, I hope you managed to do that. Remember WhatsApp line 0647488913. I hope you are trying your best there. Right, remember, greetings, I said you must highlight the work. Don't be afraid. Right, so you highlight the triangles you're dealing with. Okay, you highlight the triangles you're dealing with. Okay, let's see if I can get a highlighter here. Right, this one. Just like it's a pen, it's fine. Right, okay. That's the triangle APQ, right? And then this is the triangle DEF. You see that? Okay, so these are the two triangles. Right, now we want to prove that these two triangles are what? Are congruent. So now we're given that these two, AP is equals to DE. Okay, it's given AP is equal to DE. Right, what else? Do you have any equal angles there? Right, angle A is equal to angle D. You can see that this angle is equal to this angle. Okay, and then AQ is equal to DF. AQ is equal to DF. Do you see that? Now, can we conclude and say these two triangles are congruent? Yes, we can. We can say it's congruent because of side, angle, side. We have proved that these two triangles are what? Congruent. Okay, right, now let's go to the next question. Hence, what's the meaning of this? Hence, or otherwise. Okay, prove that PQ is parallel to BC. Right, hence, or otherwise prove that PQ is parallel to BC. It means use the answer that you got. Okay, we got this. So we have to use this to prove that. I'm going to give you 1 minute. Let's try. Right, welcome back, greetings. Right, remember WhatsApp line 064-748-8913. Ask yourself this question. Prove that PQ is parallel to PC. When can the lines be parallel? The lines can be parallel if the corresponding angles are equal. The lines can be parallel if the alternate angles are equal. And the lines can be parallel if the co-interior angles add up to 180 degrees. Remember that. This is the geometry that we started with in grade 8. We are using it even now. Okay. Right, now, what are we given about the angles? Right, we are told that APQ is equal to angle E. Okay. APQ is equal to angle E. Because of what? Because of congruency. This is like angle P and angle E are equal. Right, P here and E there. They are equal because of congruency. So these two angles are equal. And remember, we're given that angle E and angle B are equal. Angle E is Y, angle B is Y. They are equal. So angle E and angle B are equal. It's given. So now, therefore, it means angle B and angle APQ are equal. What type of angles are these ones? This angle and this angle. What type of angles are those? These are corresponding angles. Remember the F that is formed by corresponding angles. Corresponding angles form an F. The F can be oriented in different directions. Upside down or okay, whatever. But it's an F, isn't it? Right, now, these are corresponding angles. And they are equal. So what does that mean? So it means these two lines, PQ and BC, are actually parallel. You see that? Because the corresponding angles are what? Are equal. So PQ is parallel to BC. A pair of corresponding angles are equal. Okay? Right. Continue trying. I'm going to be giving you time to try things. I don't want to explain everything. And then maybe later towards the end of the lesson, I'll explain everything if we don't have time. But if we have time, I'll give you that time to do the work. 1.1.1.3. It is further given that AP is equal to 3,5, PB is equal to 4, and AC is equal to 8 centimeters. Determine the length of DF. You start by filling in the information on your diagram. You fill in this information and use what we have got. We've proved the congruency, okay? And then we've proved a lot of things. So use that to what? To try and get your answer. For this one, 2 minutes will be enough. Let's try. Well done, grade 10s. Thank you very much, Pumelelo Secondary School. We have your question. Okay, we're going to send a chat answering that question, but let me just also talk about it. Right, similarity. How do we prove similarity? There's a difference between similarity and congruency. Right, similarity is like me and my image, my photo. You see, if I take my image, I take a picture of myself. It is smaller, isn't it? It is smaller than me. But there is proportionality there. If it is out of proportion, you will say, no, this is not Mr. Ngube. The head is even, yes, I have a big head, but it's going to be bigger now. This head is bigger than what it should be. Because it's out of proportion. Or I find that my arms will be what? Longer than that what they're supposed to be, because it's out of proportion. But if it is proportion, it will represent me. If my head is reduced by a factor of 3, everything else is going to be reduced by a factor of 3. So all my things are in proportion. So the sides of triangles that are proportional, the corresponding sides must be proportional. 1. And then the angles must be equal. So for similarity is angle, angle, angle only. And then the sides must be proportional. Those two conditions. Okay? And then congruency. If I have a twin, my twin that is exactly the same as me, that is congruency. Okay, it can be side, 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 angle, side, angle, angle, side. Okay, and then RHS. Okay, right angle, hypotenuse, side. Those are the 4 of them that you can prove to use to prove that triangles are what are congruent. Okay, I hope I've answered your question. Let's continue. I said you must write the information that is given. So here we're given that AP is 3,5. Write that on the diagram. PB is 4 centimeters. Write that on the diagram. AC is 8 centimeters. Write that on the diagram. And then we're supposed to find what DF is. Right. Now then, okay, we're told that AP is equal to DE. Do you remember that? AP is equal to DE. Do you remember that? Yeah, I even use this symbol to represent that. Okay, so ADE is also 3,5 centimeters. Now, we need to use what we have. We prove that these two triangles are congruent. So now, even if you fail to prove it, you'll be given this. They'll say prove that the two triangles are what congruent. Then you fail to do it. I'm not encouraging you to fail. But don't lose all the marks. Continue with this. Continue with this information. It's very easy. Just do your eyebrows, smile. Then you continue, get all the marks, the other marks. Okay, so now we are given this, just use this. AP over what? It's AP over what? AP goes with DE. So it's AP over DE is equals to another eyebrow, BC over EF. Okay, and then the smile, AC over DF. Okay, and then you just write that. You write your proportions. Then you'll be done. Okay, even if you fail to prove it, don't lose all the marks. Just continue with what is given there. Okay, AP over DE is equal to BC over EF is equal to AC over DF. Right, let's tick what we are given and see what is not there. Right, we have AP, we have AC. What is it? Where is AC? Oh, yes. We have DE. We don't have DF. You see? And then we just take those two proportions. The AP over DE is equals to AC over DF. And then we are looking for this unknown. Now we can cross multiply, or you multiply both sides by 3,5. I'm not sure which method you prefer there. Right, what did I use here? I multiplied both sides by 3,5. Let me just explain this part. I say 7,5 over 3,5 times 3,5. Okay, is equals to 8. This one, no. This one won't work because DF here is what is the denominator. So we can multiply by DF both sides. You can multiply by DF both sides. But let's do cross multiplication. This one times this. 3,5 times 8 is equal to 7,5 times DF. Okay? Right, you say 7,5 times DF is equals to 8 times 3,5. You know cross multiplication. Okay? You can do that. Okay? And then we what? We divide by 7,5 both sides. Divide by 7,5. Then divide by 7,5. Okay? And then 7,5 divided by 7,5, you get 1. Then you remain with DF is equal to 8 times 3,5 times 7,5, which is this. Sometimes I always make sure that what I'm not given is on my top left-hand side. Okay? So I can write this thing, I can rewrite this thing in a different way. I can say DF is over AC is equals to DF over AC is equal to what? DF is equal to DE. Check that. I have 10 things around. Okay? DE over AP. You see that? And then, once I'm looking for this, I just multiply this side. This one comes this side and multiplies. Okay? It becomes DE times AC over AP. Maybe you also know that method. Okay? Use the method that you are fine with, and then you'll get the same answer. Okay, so now DF is equal to 3,7. That's what we're supposed to do there. Okay, right. Let's look at the next question. Again, I want to give you 1 minute to go through the information on your own, right? And then after 1 minute, we'll look at the questions. Try to think about the questions you may get also, okay? Right, okay, oh, the questions are already there, okay? The questions are 2.1 and 2.2, they're already there. So now let me give you 1 minute, read the information, and then after that, I'll start giving you time for each question. But now I just want you to read. Let's get used to that. There's time allocated for that. Don't rush. Read the information, look at the diagram, fill the information on the diagram before you even what? Answer the questions. Let's try that for 1 minute. Well done, grade 10s. Well done. Remember our WhatsApp line 064-748-8913. Right, let's go to our questions. I said I'm going to give you enough time to what? To try things. Okay, we still have time, so I want you to try. 2.1. Okay, let's see 2.1. Right, give a reason why E is the midpoint of AC. Give a reason why E is the midpoint of AC. 1 minute. Right. Let's see. What did you get? We have triangle ABC. Do you see triangle ABC? Triangle ABC. Okay, what do you see there? What can you say about DE? It is a line segment that is drawn from the midpoint of AB. Do you see that? What is DE? It is a line segment that is drawn from the midpoint of what? Of AB. What else? DE is parallel to BC. Then what do we say? A line segment drawn from the midpoint of one side parallel to the other side. That is DE. It is a line segment drawn from the midpoint of one side parallel to the other side. What does it do? It bisects the third side. It cuts the third side into two equal parts. So the line segment DE drawn from the midpoint of AB parallel to BC cuts AC into two equal parts, meaning that E is the midpoint because AE and EC are equal. That's the converse of the midpoint theorem. It is not the midpoint theorem. It is the converse of the midpoint theorem. There's a difference between the converse and the midpoint theorem. That's another mistake in the examinations. You come out of the examination, so no, I got that one. That was midpoint theorem. No, it is the converse. The midpoint theorem, we are not given that is their parallel. We are just given that the line segment is from the other midpoint of the other side and then to the other midpoint of the other side, to the midpoint of the other side. That's what we're given for the midpoint theorem. Here is midpoint of one side and then parallel. Then it's going to cut the other side, the third side, into two equal parts. Please take note of that. Right, that's the answer there. I've explained the answer. Right. Oh, I was busy highlighting that. Okay, it's fine. Now, I want you to try this. Now we have proved that AE is equals to EC, and we're given that ADEF is a parallelogram. Right, let's find the length of CG. I'm going to give you 2 minutes. Then after 2 minutes, we're going to discuss. Try, please don't wait for my answers. You must try, and then if you get it wrong, it's fine, but let's get it wrong first before what? Before I give you the answers, okay? 2 minutes, let's try. Right, well done, grade 10s. Let's see. We have our WhatsApp line 064-748-8913. It is further given that F is the midpoint of AG. Do you see F is the midpoint of AG? Right, what does that mean? Now let's concentrate on this triangle here. Now we know that this one is the midpoint. So midpoint E to midpoint F. Now we can talk about the midpoint theorem. So it means EF is parallel to CG, and EF is half of CG, or CG is 2 times EF. So somehow just check what could be the questions here. Before you even look at the question, look at the information. What could be what can I apply in this? Right, we're told that F is the midpoint. It is further given that we've proved that E is the midpoint, and then it is further given that F is the midpoint. So somehow I'm going to be asked to apply the midpoint theorem here. Because E is the midpoint, F is the midpoint, they can ask me a question, application question, or even proving that. Okay, right, now I know that EF is half of CG. I know that CG is 2 times EF. I know that EF is parallel to CG. Let's see what they're asking us here. ADEF is a parallelogram. Let's highlight that. Don't be afraid to highlight that. Oh, I've added that information there. Right, let's highlight that, the parallelogram. Right, and then BD is root 32. I put that information there. This is a parallelogram. Right, BD is root 32. Okay, meaning that AD is also root 32. You're given that AD is equal to what? Is equal to BD. So this is also root 32. Can we say EF is root 32? Yes, we can, because the opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal and parallel. Remember that. And then what will be CG? The length of CG. What do you think? It's going to be 2 times what? 2 times root 32. Okay, and then you put it in your calculator, you're going to get this. 8 root 2. Because this is like 2, root 32 will be like 16 times 2. Then the square root of 16 is 4. It comes out, becomes 2 times 4, root 2. And then 2 times 4, there is 8. It's going to be 8 root 2. Okay, but you can put it in your calculator. It will come out nicely. Okay, that is that. Right, so that is there. Right, question activity 2. Now, because of time, I'm going to explain the activity. But if you want to try to be ahead of us, of everyone else, try to do that. Don't wait for anyone. Okay? You see, these questions are coming from what? From past examination questions. Okay? Right. In the diagram below, D is the midpoint of AB. Is it indicated? If it is not indicated, I have to do that. Yes, it is, because of this. Of triangle ABC. You see triangle ABC. Okay. E is the midpoint of AC. Interesting. D the midpoint, E the midpoint. What do I sense here? Midpoint theorem. Before I even look at the question, DE is produced to F. It means extended to F, such that DE is equal to E. This sounds like what we did when we were doing the proof. DE is produced to F, such that DE is equal to EF. Is it indicated? Yes, it is indicated here. And then CF is parallel to BA. Is indicated? Yes, it is indicated here. I'm sensing here. I can even see before doing anything that this is a parallelogram. BDFC is a parallelogram because DE is parallel to BC, midpoint theorem, because I've seen the midpoint theorem. You see that? Okay, try to understand the information before going to the question. You can't answer the question before you understand the information. You can't. Some of you rush to the question, then you want to understand the information after that. That will not work. Understand the information that you're given before going to the questions. Write down the reason why triangle ADE is congruent to triangle CFE. We have done something like this. Highlight the triangle so that you can see them nicely. ADE, and then triangle what? CFE. Okay, you see that? Now, why are they congruent? I can say side, 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 because this side goes with this side. This one goes with that. No. We don't have the third side. We can't, as this one, we don't know. Okay, so we have side, angle, side. Side, angle, side there. Okay, because these are vertically opposite. So now the two triangles are congruent because of side, angle, side. Now we've proved that these two triangles are congruent, meaning that AD is equal to CF. Okay, so we can conclude and say AD is equal to CF. These two sides are equal now because of congruency. You see that? Like what we did when we're doing the proof, if you check. This question is like that. Okay, two sides of an angle, two sides and an included angle. Right, write down the reason why DBCF is a parallelogram. Right, we prove that this side is equal to this side through the congruency. So now if you check, AD is equal to BD and AD is equal to CF, meaning that BD is equal to CF. Even if you look at this is equal to this, and then this is equal to this, meaning that these two sides are equal. So look at BD, look at CF. There are two conditions. One, they are equal. Two, they are parallel. So you have a pair of opposite sides that is equal and parallel. Therefore, DBCF is a parallelogram. Okay? Hence, prove the theorem which states that DE is half of BC. Now we've proved that this is a parallelogram. It's like the proof question if you check, but it came out differently without telling you to prove. Okay, you see that? Right. We say this is a parallelogram, therefore this side and this side are parallel, and this side and this side are equal. Okay, let me use three. There are three lines. Okay, it's fine. I'm using different color anyway. Right, so DF is equals to BC and DF is parallel to BC. Right, and then remember DE is equals to half of DF. But DF is equal to BC, so we can replace there and say DE is equal to half of BC. You see that? Right, so that's what you're supposed to do there. Okay, opposite sides of a parallelogram. So DF is equal to BC, so we can say DE is equal to half of BC. We have replaced DF there with BC. Do you see that? Okay, so this is what we're supposed to do. Right, and then these are the few questions that we managed to share, right, from past examination questions as we prepare for our final examination in 2021. Please make sure that you try to use the information you have gained here. Right, I'm going to give you 1 minute to copy the question. There are 2 slides, isn't it? After this, I'm going to go to the next slide and then we write the questions, isn't it? Then we'll just summarize our lesson. So what is it? Okay, 1 minute on the information. You don't need to draw 2 diagrams because this diagram is just one thing. So when you come to this slide, just copy this. Okay, so 1 minute for this and the diagram, and then I'll give you the other minute to copy the questions. Let's try that. Welcome back, greetings. Again, Pumelele Secondary School, thank you very much. Thank you very much, grade 10s. Thank you very much for letting us know that you have understood. It really means a lot to us. It really means a lot. Okay, so let's go to the questions now. Don't copy the diagram now. Just this part which I've circled. Just do that, and then 1 minute, and then we go to the summary. Let's try. Right, let's continue grade 10s. Right, let's go to our WhatsApp. We've done our WhatsApp part. Right, to summarize, let me just remind you about the things that we must take note of as you prepare for examinations. Remember, grade 10, this is not enough. Don't say now you've done this lesson is enough. No. After this, go straight and look for past examination questions. They will assist you a lot. And make sure you apply what you have learned. Okay, you continue looking for information, for knowledge. Okay, right, and then give the correct and complete reasons. Let's do that in our examinations. Right, name English correctly. Let's do that in our examinations. And then do not make wrong assumptions. Don't assume. Please remember that. Don't assume when you're doing especially geometry, Euclidean geometry. Indicate constructions when proving theorems. If you're asked to prove, please indicate what the constructions. You do this up to your till you write your matrix. And make sure the construction is there. Okay. Thank you very much. You can press complete once you're done. And then thank you very much. We're going to do our revision program, and we'll do paper 1, and then after that we do paper 2. We'll cover the topics that we did not cover during these last 2 lessons. Keep safe, take care of each other, and continue working hard. And remember to sanitize, to social distance, and to wear your mask. Thank you very much. Let's meet in our revision when we are doing our revision program. Thank you.